Hey there, everyone. Welcome back to the channel. Today, we're diving into a fascinating story about how AI is revolutionizing the field of physics, specifically in the study of jamming. Now, you might be wondering, what is jamming? Well, imagine a box filled with tennis balls in zero gravity. As you add more balls or inflate them, the space between them becomes scarce, and eventually, they lock up into a solid, rigid structure. This phenomenon, known as jamming, has been a long-standing puzzle for physicists, but now, with the help of AI, a Nobel laureate and his colleague have finally solved it. What makes this even more intriguing is the AI model they used, called Claude, which is developed by the company Anthropic. This story highlights how AI is not just a tool for automation, but a powerful assistant in complex problem-solving, even in fields like physics that were once thought to be beyond the reach of machines. So, let's explore how this AI-assisted breakthrough works, and what it means for the future of scientific research. First, let's talk about the problem they were trying to solve. The concept of jamming is a bit like a traffic jam in a box of spheres. It's a sudden transition where a fluid system becomes rigid, yet remains disordered. This phenomenon has been studied in various fields, including neuroscience and artificial intelligence, where it's related to the way neural networks process information. Now, the physicists, Francesco Zamponi and Giorgio Parisi, had been working on this problem for a decade, and it was a real head-scratcher. They were trying to understand how these spheres, or in the case of neural networks, synaptic weights, lock up into a solid state. The breakthrough came when they decided to involve AI. They chose Claude because of its advanced coding and mathematical reasoning capabilities. The AI model was first asked to replicate the numerical calculations they had been working on for years. Once it successfully reproduced those results, they asked it to prove the mathematical relationship they had discovered, which was that two parameters, A and B, add up to 1. Now, this might sound like a simple equation, but it was a complex problem that had eluded them for a decade. The AI model, with its iterative refinements and verifications, provided a new perspective, revealing a simpler solution that they had initially missed. This breakthrough not only confirms the physical laws, but also opens up new avenues for research. Zamponi believes that AI could be as significant as the Industrial Revolution, or the birth of the Internet in terms of its impact on scientific research. It can act as a telescope for the mind, allowing scientists to test ideas at unprecedented speeds and lower specialization barriers. However, he also raises concerns about the potential downsides, such as the production of poor quality, pseudoscientific research, and the need for better peer review systems. To address these issues, Zamponi and his colleagues chose to publish their full conversation with Claude, believing that transparency is key to responsible AI usage. Now, let's shift gears and talk about another application of this AI-assisted approach. Zamponi is now applying it to a problem involving random sequential absorption, RSA, of hard hyperspheres. RSA is a classic protocol for generating random packings, which is crucial for understanding the geometry of void spaces and packing efficiency. While RSA and jamming transitions describe how systems of hard spheres lock up, they represent different physical processes. Jamming involves mobile particles that rearrange until a rigid state is reached, while RSA is an out-of-equilibrium, irreversible process where particles never move one's place. This distinction is essential in understanding the behavior of these systems. So, there you have it. AI is not just a tool for automation, it's a powerful assistant in complex problem-solving, even in fields like physics that were once thought to be beyond the reach of machines. It's an exciting time for scientific research, and I can't wait to see what other breakthroughs AI will help us achieve. Thanks for watching, and don't forget to like and subscribe for more fascinating content. See you next time.